one more method, that is graphical method of solving LPP. So far we have seen only LPP. This is graphical method of solving LPP programs. For this you require a graph, students. Okay, so here when we come across this question, solve the problem LPP where that is the profit function is given z max is equal to 100x plus 40y in the question. Subject to constraints are 5x plus 2y less than or equal to 100, 3x plus 2y less than or equal to 90, and non-negative constraint is x comma y greater than or equal to 0. Now let's solve the problem. Question is given, let's solve the problem. In this also I have given you the steps. We have to follow those steps to solve this problem. So step 1, formulate LPP. So this is the same thing we are going to write here. That is object function or you say it as maximizing of profit. That is z max is equal to 100x plus 40y. Subject to constraints as given in the question. First one is 5x plus 2y less than or equal to 100. Second one is 3x plus 2y less than or equal to 90. And non-negative constraint is x comma y should be greater than equal to 0. So this is your step 1. Step 2, equalize the unequal constraints. Equalize the unequal constraints, that is we are going to take one and second equation, that is 5x plus 2y should be equal to 100. This is your equation 1. Then 3x plus 2y should be equal to 90. This is your equation. So this is your step 2, students. Now step, I am writing here, students, it's step 3. Now coming to step 3, students, what you need to do is you need to find the cardinal points for these equations. Okay, find the coordinate point for the equations. Okay, so how are you going to find the cardinal points for the equation? First we will take the first equation, that is 5x plus 2y should be equal to 100. So first equation we have taken. Now first thing is let x is equal to 0. Now x we are taking it as 0. So it is 5 into 0 plus 2y equal to 100. So this becomes 0. 0 plus 2y is equal to 100. So 2y is equal to 100. Y is equal to 100 by 2. So y is equal to 50. Okay. So here you will write it as 0 comma 50. X value is 0. So it is 0 comma 50. Okay. Now for the same equation, let y is equal to 0. Okay. So it is 5x plus 2 into 0 is equal to 100. That is 5x plus 0 is equal to 100. So it is 5x is equal to 100. Then x is equal to 100 by 5. So it's x is equal to 20. So you will write it as 20 comma 0. This is only for first equation. In the same way you have to find it for the second equation. Okay, that is 3x plus 2y is equal to 90. Okay students, So here it is, let x is equal to 0. Then we will write it as 3 into 0 plus 2y is equal to 90. That is 0 plus 2y is equal to 90. 2y is equal to 90. Y is equal to 90 by 2. Then y is equal to 45. Okay, so it is 0 comma 45. Then same way, let y is equal to 0. Okay, so here it is 3x plus 2 into 0 is equal to 90. So 3x plus 0 is equal to 90. So 3x is equal to 90. X is equal to 90 by 3, which is x is equal to 30. Okay, then it is 30 comma 0. So we got the cardinal points for that. Now the step 4 is, using these cardinal points you have to plot them in the graph. Okay, so for example, I am drawing the graph here. Y-axis, x-axis, this is here. What I am going to do is, I am going to take the scales of 10, okay, or 5, whatever you can take it as. I will take 5, no problem. 5, 10, 15, 20, 25, 30, 35. That's it. Here I'll take it as 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay, so I'm taking it a scale of 5 unit. Okay, so here in the first point, if I see only this equation, it is 0 comma 50. That is x-axis is 0 and y is 50. Whereas here it is 20. Okay, 20 comma 0. Y-axis is 0. So I join these 2 points. This is the first equation. Now I take this second equation, this one. Okay, so here it is 0 comma 45. X is 0, y is 45. So here I take the second equation and here it is 30 comma 0. So x is 30 here. So again I will join these 2 points. Okay, so my feasible region will be here, because remember students, everything is less than, the graph will come inside. If it is greater than, then graph will go outside. Okay, so this is my feasible region. I put the graph values inside. Okay, here this is A, this is B, and this is C. Okay students, this is your step 4 mark. In this step 4 we have plotted the graph and we have got this feasible region, the part A, B and C. Okay, this is 0 comma 45, B is 5 comma 37 and C is 0 comma 20. So this part is our feasible region students. And now step 5, what we need to do in step 5 student here is, we need to, whatever the feasible region we have got it, using this feasible region you have to substitute in this object function. You have to substitute these values of this feasible region in this object function, and from that you will get the optimum solution. Okay, so here we are putting these feasible values in the object functions. Okay, plot the feasible region values, or you can say substitute also. Substitute the feasible region values in object function. Here object function is z max is equal to 100x plus 40y. Now here you have x and y values. First we will take it as a. What is a? 0, 45. So we have to substitute these values in this. That is 100 into 0 plus 40 into 45. So it is 0 plus 40 into 45 is how much? 1800. So it is 1800. Okay. Then next b. Same thing. You have to substitute those b value in that. That is 5, 37. We got it as per the graph. Okay. So here it is 100 into 5 plus 40 into 37. So it is 500 plus 40 into 37 is 1480. So 500 plus 1480. 1980. Then same way we have to do for C. Can I erase this question, students? Okay. Here the third C is 20, 0. That is 100 into 20 plus 40 into 0. That is 2000 plus 0. So it is 2000. Therefore here step 6 is the optimum solution from the feasible value substituting in object function is maximum value. Here we have it is 2000. See here it is 1800, 1980 and 2000. So here 2000 is your optimum solution. Okay. So like this we have to solve the graphical method for LPP. Thank you. Z max is equal to 2000. This is the last step you need to write. Z max is equal to 2000.